Hello everyone, how are you guys doing? I hope you're all doing amazing. Welcome to another video on this channel. Now, the last time that you must have visited a stream on this channel, which is a long while back now, we were doing Golang exercises on exercism. Now, from today onwards, we are starting off a new series where we'll be solving the top interview 150 questions on LeetCode. Now, we will be solving these questions using Golang. And when I was searching YouTube myself, I couldn't find any good resources which were using Golang to solve DSA problems. So, in my knowledge, I'm the first one doing it. If you have any more references, just let me know in the comments. Maybe I'll explore some content for myself. But here we are doing it. Now, done some of these questions already, and I'll just be going through them once again with you, as teaching is learning twice. And yeah, in these videos, we'll try to generalize the problem as much as possible. We'll try to spend a little more time with the problem than the usual other videos do. And we'll also try to understand some of the Golang specific things if we come through any nuances or any of the concepts that we see, or some basic concepts as well. So if you're new to the language, this series is to make you more familiar with it and at the same time brush up your DSA skills. So if you're someone who has not programmed for DSA specifically from a long while, this can help you brush up those skills. If you're someone who is just starting off with Golang and want to get familiar with the language more and understand the functions better, this is great for you. Or you are an experienced programmer who just wants to brush up their DSA. Well, here you are. Here's the series. So without any further ado, let's get into the first question. So the first question is merge sorted array. You are given two integer arrays, nums1, nums2, and you want to sort them in they are already sorted in non-decreasing order. You want to merge them so that the final array that is formed is also in non-decreasing order. Now, the only twist in this problem is that you don't have to create a third array using these two arrays, but you basically want to fill in the sorted array in the nums1 array itself. So I think pictures are a better representation than word. So let's get into it. This board is locked. Why would it be locked? That's weird. Okay, so you have array 1. Let's take in the example that they have given us in the problem, which is your 1, 2, 3, 0, 0, 0. Now, why do we have the 0, 0, 0? Always, from any of these videos, try to take 5 minutes to read the question first and then get into the video, because I don't want to waste too much time into reading the problem and going through every nuances. But just for the first one, we can go through it, that basically your nums1 has a length of m plus n and your nums2 has a length of n. And in your nums1 till m, your elements are filled in non-decreasing order, but after that they have filled zeros so that you can replace them with the values in nums2 so that the final array forms a sorted array. But yeah, from later videos, we'll try to focus less on the questions and try to spend more time in in the solution of the problem itself. I'm writing through touchpad right now, so don't mind the writing. I know it's pretty bad. So these are your two arrays, and you basically want to merge them so that your array 1 becomes a merged array of array 1 and array 2, and it is in sorted order. So what you basically want to do is, in some sense, is first of all, let's first write the output that these two arrays will make. That is actually expected of us in the problem, which is 1, 2, 2, 3, 5, 6. Now to get to this, we need to first understand how do we actually think about these problems where we have two arrays and you have a final output. So let's see the first array, which contains these elements, and this is your second array which contains these three elements, and we basically want to get this output. Now, if you look at it carefully, in some sense what you are doing is you are picking values from array 2 and putting them in some position at array 1 based on the order of their value, and that way you are just filling it up. Now the only nuance is that you can't just fill them up in any order, because if you start filling them up randomly, uh, if you just start overwriting these values, then your array 1 information will be lost. So somehow you want to fill in the values from array 2 in array 1 in reverse order, so that first of all your zeros are filled up in whatever order possible, and then you finally overwrite these values. Now, why do I talk about overriding these values as such, and how it will happen if my array 1 values were greater. So let's think about it. So basically what we want to do is, let's say you had some larger values in array 1 instead of the values we have right now, which are all small. So this will be what your array 1 will look like. And somehow what we will be doing is, you'll be pushing all of these values right here and placing these values in front of it. Now I know that makes the question look even more confusing, but let's just figure it out. So this is what you have to achieve finally. Now to achieve this, what you are doing is, you are looking at the elements of both the arrays, and to fill in the last element, you want to pick the greatest from both. Now, how do you get the greatest element from a non-decreasing array? You point to the location of its maximum value, which is its last index. Now, you are given m and n, which are your final lengths of both of the arrays. So, your pointer should be at n minus 1 when you start for array 2, and your pointer should be at m minus 1 when you start in array 1. And you basically want to compare these values and fill in the maximum value out of these into your array 1 last element. Now, how do you maintain this last element, which is your last filled element in a sense? Because once you have filled a value in it, you don't want to be filled it in again, and you want to decrement it so that you now find a value for this index. Now, to do that, you have to maintain another variable k, which stores the value of m plus n minus 1 plus n minus 1, and you will keep decrementing it as you iterate through both of the arrays, and you will just stop when you have finally reached the end. Okay, that makes sense. Now, how do we fill in these values? So if we iterate through, so if we look at the problem as we discussed earlier, we are just trying to fill in the values from array 2 into array 1, and but at the same time we'll also have to look at the values of array 1 itself to see if they are not as much, like if they are not greater than the values of array 2, and they need to be the one that placed in the last. So what we are doing is, we'll compare the values at m minus 1 and n minus 1, and we'll see whichever one of them is greater, and we'll fill it this value inside of it. Now, so what do we iterate on? Uh, in some sense, we want to keep iterating. Now, let's have one more observation before we get into it. So in the first example we took, we saw that we filled in our 6 because that was greater when we compared these 2 points. We filled in the 6 here. Now we decremented the point here. Then we filled in 5 because that was greater than 3. Then we again decremented the pointer and came here. Now we filled in 3 because that was greater. And then we decremented the point there. But in some sense, once your values of 2 are over, if this 2 was also filled, let's say in this value we had the logic that if values of array 2 are greater than or equal to, we'll fill in the values of array 2. So let's say this 2 was filled in from this index. Now once you have filled this index, you basically have to keep the elements of array 1 in the same order because they are already sorted. So if that makes sense, that should tell you that to actually get this value, we have to iterate over array 2 till its value becomes 0, and we at the same time we'll also keep checking array 1, but it doesn't matter if array 1 actually leads to 0, because if array 2 is empty, then we know that the other elements that are left in array 1 are already sorted. So with that, I think we have an intuition about this problem, and the basic generalization things that we can observe from here were, the first one being how we can use the outputs to actually visualize what we have to do in the problem. So we looked at both the actual output that we wanted in 2 or more cases, and we tried to understand that in some sense, how can we simplify the problem by observing what we are actually doing to actually merge these arrays. Because if you have to fill in array 1, you are basically have to iterate array 2 and decide on which locations they need to be filled. And the other thing was to use another variable k, which defines your final output goal, which needs to be filled and is maintained irrespective of how you are filling in these values. So it's a simple problem. It's an easy problem. There is not much creative kind of you can say observations here that will actually help you in other problems. These are more of the standard things that has to be with you when you are solving bigger problems. These are the things that would be expected of you, that you understand this much, and the higher order problems will be built upon these logics. But I think this goes to show like some of the simplest ways you can think of a problem when you are first stuck with it. You can try to apply these kind of ideas to it, that if I try, how can I try to simplify it? Can I use another variable to define my problem for me, and stuff like that. So enough of talking around it. Let's finally get to coding it. So okay, I've already written a code here. Let's just reset it and try to write it again together. So as we discussed earlier, we'll be maintaining a variable which is our k, which will point to our m plus n minus 1, and we have another pointer which is our pointer 1, which will be pointing to our m minus 1, and we have a pointer 2 which will be pointing to n minus 1, because we are iterating through reverse. And why are we iterating through reverse order? Because the zeros are filled in here. For example, if the question was the other way around, for example, if there were zero values in the initial part of the array and our final values were here, we would have preferred to do it the other way around. We would have thought of using these arrays, like filling up with the zeroth index first, and we would have compared the minima at that point and filled in those values first. So that is one different way interviewer can ask you from this question. And yeah, I think that is a very clear cut way, like that should be understood to all of you. But yeah, so those are basically the ideas you have to use. And yeah, just try to think in reverse order whenever the straight order doesn't make sense, or your values are getting overwritten and you have been provided additional variables that you can override at the end of the array. Okay, yeah, I think I've generalized it enough. I'm maybe overdoing it at this point. So what we discussed was that we want to iterate through the array till our pointer 2 becomes less than 0. And once it is less than 0, then we can actually leave the nums1 array as it is. We don't care if it has already reached 0 or not, because we already know that the values will be sorted for it. Now, if you are not aware of Golang that much, if you have just started, you should understand that this is a short variable declaration. Golang is a static language where your variables needs to be of the same type when you are reassigning them. But at the same time, you can actually don't need to always specify your variable type like you do in C++. Golang can actually infer your type for you. So when I'm doing this, it understands that it's int plus int minus int. So k should be a int. And if I try to ever in my code ahead try to do k is equal to string, it will give me a compilation error and not single quotes. That's a bad habit from Python. Will be using double quotes. So yeah, so if I try to run this, let's just also, we don't need to return anything in this problem, as we want to uh, just update these values in place. So let's just try to run this, and you will see a compilation error saying that k is an int and cannot use string. So yeah, very basic Golang thing. I think most of you, if you are watching this video, are aware of it. But just to cover everything else for anyone who was not aware of short variable declaration. But okay, so we want to iterate through p2 till it is greater than equal to 0. If it is reached out of it, then we are done with it. And let's do not if, it should be for. So in Golang, your for loop works both as a while loop and for loop of Python or any of the other programming languages as such. So you can use your for loop in the standard way, where you use your for loop p2 and you first declare it to some value, let's say n minus 1. Then you put in a condition, and then you finally put in the update condition. So that is one way of doing it. But yeah, this will lead to a, yeah, this should be it. So this is one way of doing it, which is your very classical kind of a for loop way that you use in JavaScript, C++, and stuff like that. But you can also use it as a while loop. So you basically put in your condition here, all of your update logics will be inside of the code, and it will just check for this condition. So that's kind of cool. They provide you less keywords. I like that about Golang. Now, to update this, we basically want to check if p1 is still greater than equal to 0. So if there is any value left in p1 at all to be filled, and We also want to check if our nums1 p1 is greater than nums2 p2. If both of these conditions are satisfied, that there is still value in p1 and that value is greater than the value in p2, this will be nums1. At that point, we want to fill in nums with nums1k with value at nums1 p1 as it is greater than the value at p2. And if there is any other condition, whether our p1 values are emptied now, there is no more value left in p1, or p2 is actually greater than p1. In both of those cases, we'll want to fill in nums2k with our nums2 p2. And again, my bad, this should be nums1. And when we are filling in a value from p1, we want to decrement that pointer. So p1 should be decremented if this path is followed, and p2 should be decremented if this path is followed. And if any of this is successful at each iteration, we want to reduce k because k is always getting filled. So this should update everything in place, and we should be able to receive our final nums, which is the sorted merged array. So let's just run this. Cool, it is accepted in all of the three problems. I hope you're able to see it. My face is not covering too much of it. Uh, Also, let me know if this zoom level was too small and you were not able to see the characters properly. I'll try to keep it like this from next time onwards if that's too much. I think my face is still not covering the test cases. So this also works for me. Yeah, just let me know which one worked better for you. And that's it. That was the first video of the series. I hope you understood this problem and what we are actually trying to do in it. And you have unlocked some more techniques you can observe an array once you are given a problem either in an interview or in a OA round, like whatever it is. So see you guys in the next video.
Why are you running? Why are you running?
We also need to submit this problem first. Really forgot that. That's the thing we need to do. Yeah. So it works with, it beats 100% of the people because it's Golang and the memory efficiency is also great. So clap for us, I guess. Cool. So that was all for this video. See you guys next time. Bye bye.